Okay, this is the snow accumulation Q&A for 3D World Magazine. Okay, so basically starting with the snow accumulation start max scene that's included with the magazine, and in this scene we've pretty much got a few objects in here. So if I just pull up the select from scene dialog, and we've got a few standard objects. So we've got a plane for the obviously the ground, teapot, a box, and a torus knot for our collision and accumulation objects in here. We've got a deflector object, bring that across, which is going to mimic particle interaction with the ground surface. This is purple object here. Particle flow source icon already set up, which is situated above here to emit the particles, i.e. the snow. Gravity is obviously bringing them down to the ground. A initial wind space warp, which is this guy here. If I just pull that across, you can be able to see it. There we go. So we've got like a wind that's been blown, it's blowing the particles across this way. Got a low strength value, so they're kind of being gingerly blown across the scene. And we've got a value of 1 for the turbulence, frequency of 5, and a scale of 0.03 for the scale, which is gonna kind of get this breakup like this kind of thing. We've also got another wind space warp in here as well, which has got no strength on the force for directional force. Same value for turbulence, same frequency, but this time we've actually got a lower scale value, which is going to generate a larger noise distribution pattern like this. We've got a few U deflectors in here as well. So we've got one here for this box object, which is assigned here. No bounce in there, just purely for safety, because we're just going to get these particles to come to rest. We've got one here as well, and one over here as well. So again, we've got all these individual geometry items are loaded into the individual U deflectors. Okay, so what we can basically do now is using this particle flow source icon, which is set to a length and width of 600, so it kind of encompasses the objects that we want to scatter the snow onto. Viewport quantity multiplier is set to 100%, which is exactly the same as the render. We're not actually going to be rendering this thing out. We're literally just going to be using this to position the particles over the geometry and then bake the entire thing down. The system management, I've actually cranked this upper limit value up to its maximum value for the 32-bit version of 3ds Max. Okay, so first things first is we need to obviously set up our emission of particles. So the first thing we need to do is we need to add in a birth event, and that's just this guy here, and I'm going to rename that. Let's call that, or simply get my caps lock off, birth. There we go. And we want to set the emit stop value to the length of the scene, which is going to be 100 frames, and the amount, I'm actually going to set that all the way up to about 500,000. 500 and 3 zeros at the end. There we go. Wire the output of this guy into the input of that. Okay, so the next thing we want to do is obviously we need to say where the particles are actually going to be born from. So let's drop in a position icon operator, which is this guy, and it will just leave that at volume. So if we start scrubbing through, we can see an absolute ton of particles being born, but they're actually going nowhere fast because there's no obviously speed or forces applied to them at the present time. So let's apply those now. So let's drop in a force operation. I'm going to split these up into two batches. One is going to deal with the gravity, and the other one is going to deal with the two wind space warps, so we can control them both independently directly within particle view, as opposed to going back to the space warps and having to manually dial them in the command bar over here. So first things first, let's drop in the gravity. Okay, and then what we'll do next is we'll drop in the wind space warps. So reorder that and add in those two guys there. Now these default values are going to be pretty high to start with, because the default with the influence percentage of 1000. So if I just scrub through, you can see these guys falling pretty quick. So you can see the distribution patterns of the two wind space warps kind of creating this irregular pattern here. It's the reason why we've added two in, just so it breaks it up, so we get like a nice distribution of particles as opposed to kind of like a uniform breakup. Okay, so let's set this gravity value down. So let's actually go through and set that to a value of about 200. So that will have these guys, I'll just play through this, just scrub through, having them all kind of breaking up nicely and then swirling and across the scene like so. Now you'll notice there's an absolute ton of particles which are not going to be interacting with our geometry whatsoever. So in the next event what we'll do is we'll make sure that after a certain amount of time these guys are deleted, so just to keep the memory calculations down a bit, because we're obviously going to be dealing with a lot of particle-particle interaction calculations. Okay, next thing we need to introduce is an age test, and that is purely implemented so that the speed test, which we'll introduce in a second, doesn't check for low speed values immediately as soon as the particles are actually born, otherwise they'll produce a true value, a true result to the test, so therefore they'll just get piped straight through to the next result, sorry, the next event, and you'll have a collation of particles which are just static around the icon there. So let's drop in a value in here, so set it by particle age, and we'll set the test value to 10 with no variation in there at all. Okay, so the next thing we need to do is we need to have the same kind of force values applied into the next event, so the particle animation is consistent. So let's just instance those across, and then we can wire the output of this guy into the input of this one here, and let's just label this as well. So we'll call that accumulation search, because it's basically searching for interactions with the geometry. And in this particular sequence, what we're going, sorry, in this particular simulation, what we're going to do is we're going to simulate the particles actually just brushing across the ground. We're not actually going to have them accumulating on the ground, just around the base of the objects and on the objects themselves. If you actually want to get the particles to aggregate on the ground as well, you can simply just wire the output of the first collision that we're going to introduce into the accumulation event, which we'll situate down here and we'll add in a second. So first thing is we'll just drop in a collision test, which is the deflector, which I was speaking about just a second ago. So let's add that guy in, and then let's add in a test for the other two space warps, sorry, the other three space warps in there. Okay, so that's those guys applied. Next thing we need to do is add in let's drop in the delete operator in there as well. So after a certain amount of time, i.e. after about 40 frames after birth, we can delete these particles. So if they're kind of like passed over the side of this teapot and are not obviously going to be interacting with it, we can get rid of them. Okay, so the next one we want to drop in is a keep apart operator. Now you've noticed I've actually added this all the way down at frame 0. By default the scope setting is set to current event, so obviously there's going to be a hell of a lot of particles in this event as well. So what we basically want to make sure of is that the system doesn't crash. Now keep apart is pretty much a brute force operator, i.e. it will test the entire scene and test every single particle that it calls on, and as a result it can lead to failures, it can lead to the actual system hanging. So I would suggest at this particular point what we'll do is we'll do a quick save here, and I'm going to save that as finished, so you'll have this because I'll keep on saving it as we progress through, so you'll have this scene once we've actually completed it as well. Okay, what I'm also going to do is I'm going to set a few values in here. So what I want to do is I want to turn off this acceleration limit, so the particles will simply just come to an almost virtual standstill, and I'll set the speed limit all the way down to a value of 1. So what this is basically going to do is as soon as one particle comes into collision, comes into a close proximity, which is derived from these core radius and fall off zone values, the particles speed is going to be pretty much clamped all the way down to a value of 1. So they're traveling pretty fast to start with, and then all of a sudden when they actually come to a proximity, they'll slow right down. Now what we can do then is we can drop in a test to say, okay, how fast are these guys going? If they are less than our test value, and our test value, I think what we'll do is we'll go and set that in to a value of 2 just for safety, because if we set it to a value of 1, the particles aren't obviously going to be travelling less than a value of 1, they're obviously going to be travelling at a value of 1, so therefore the test will more than likely not produce a true result. So okay, so with that value set in there and these guys set in there, let's just jump quickly back into this guy here. Now, two things to understand about keep apart. Okay, one is that the core radius is basically the radius, obviously, of the particle, and the particle relative to particle size is derived from the size and scale of the particle shape. Now, we haven't actually set the particle shape within the system so far. If you notice, there's no shape operators that have been introduced. So what we'll do is we'll set the values in here. I'll set it pretty low, so we're going to set that to about 2.5, and the fall off zone I'm going to halve that, so about 1.25. One thing to note, like I said, the second thing to note, as I mentioned earlier on, keep apart can be pretty unstable. Now, using this absolute size method as opposed to this relative to particle size method is more stable. You will more than likely get a completed simulation this way than using this option here, so bear that in mind for this specific scenario, and also for any future ones you decide to do later on. Okay, so with this event pretty much set up now, so what we can do is create another event, and this one I'm going to set it to a shape event, and this, let's just rename it, so let's call that accumulation. Okay, I'm going to set this shape operator over here, I'm going to set that to a value of 5, and I'm also going to set the shape to sphere, just purely for viewport representation. That's all. It doesn't really matter what kind of shape you actually use, quite simply because the blob mesh compound object we're going to be using later on is going to surface it based on the size value alone. Okay, so we need to now wire in the input, wire the output of this collision test into the input of this accumulation event, and also the output of this speed test in there as well. So therefore, when the speed value, i.e. gets close to an adjacent particle, is below this test value, then the particles are sent into this event and are given a shape size. And also when the particles hit this, any one of these three deflectors, which are obviously any one of these three objects, they are piped into this event as well. Now, we obviously need to make sure that these particles are tested for interaction, i.e. using this keep apart and this speed test, just with this one specific event here. So therefore we can just, in this keep apart, we can just say, okay, we just want to check for particle interaction with selected events, and it's just this guy there. So one last thing we need to introduce, and that is, well, a couple of things. Let's just set the type in here to geometry so we can see exactly what's going on in the viewport, and we want to kill the speed of the particles so that they are not moving as soon as they actually hit any of these deflectors or interact with the keep apart and the speed test. So for that, just drop in the speed operator and set the speed to 0. Okay, so at this particular stage, what we really want to do is to save the scene, quite simply because we now need to go through and set up our blob mesh and also perform the simulation. So let's set up the blob mesh first, and that's in the create tab, compound objects, and let's just drop a blob mesh in the top viewport. I'm going to center that right in the middle of the scene, and let's just set up some of the properties in here. Okay, so the first thing I want to do is I want to add in our particle flow source icon there. Let's turn off that, and we don't want all particle flow events, otherwise we'll have a lot of surface geometry all the way around, all the way down here and across the surface and so on and so on. We only want them on the particles which have aggregated on the geometry objects here. Okay, so let's turn that guy off and then click on add and then just choose the accumulation event there. Now what I'm going to do first is I'm going to turn off this off in viewport option. Now what that allows us to do is to perform the simulation first, and then we can simply, when we actually get to frame 100, we can turn this guy off and it will calculate the blob mesh separately. Okay, so one last thing we want to do in blob mesh before we start performing the simulation, and that is to just go through and set the correct viewport evaluation coarseness value in here. Now this guy is it's a kind of like an inverse to mesh smooth, if you will. Best kind of way of describing it. The lower the value, the more refined the geometry is. So this value here is obviously going to be pretty low detail as opposed to this guy here. Now what that pretty much does is it will approximate a lot more between particles. So because these particles are quite small, we actually want the the viewport evaluation coarseness to be pretty low. So for this particular one, we want to drop it down to a value of 3 as well. Okay, so that's pretty much our scene setup. So I'm going to save it again just for safety, and I'm going to click on the play button. Now before I do, I just want to quickly bring up something that I've set up in here already for you guys. I've taken real time off, so therefore it will go through every single frame incrementally and won't just jump all the way through to like frame 50 or frame 100 or so while the system's trying to catch up. I've also taken loop off, so therefore once the system's gone all the way through to the end, i.e. to the end of this sequence here at frame 100, it will simply sit there. One other thing I would advise you to do at this present stage is obviously save the scene. Also, you will more than likely want to turn off auto backup. Now the reason behind that is quite simply because once this clock, this 5 minutes, has counted down, 3ds Max will automatically create an auto backup file. Now the problem with that is that it will then recalculate the particles all over again. Okay, so therefore you'll have to go through the entire recalculation again. Now bear in mind the amount of particles that we're dealing with. We're dealing with 500,000 of these guys, and we're dealing with a lot of particle interaction, so this will take a long time to do. It will more than likely take, depending on the speed of your system, possibly about 20 minutes, possibly 40, possibly an hour. I'd say the best thing really is if you click on the play button, and once that's generated either a decent amount of particles for you to work with, or has gone all the way through to the end, you can basically resume this tutorial, and we'll finish off by sorting out this blob mesh and any kind of modifiers that we'll add afterwards. Okay. One thing you might notice is that the sequence, while you're playing through, it might suddenly just get to a certain point and then just suddenly stop. So what you might want to do is just suddenly just jump all the way to frame 100 just by clicking over there, and that will now start to calculate the particles down here. You'll notice this. Well, obviously the hourglass has decided to start working away there, and it'll build up behind the scenes. And again, this will take a substantial amount of time, so I'd say go off, have a bite to eat, have a cup of tea, whatever, and I'll see you on the other side. Okay, with the simulation finished, we've got this nice kind of distribution pattern here. We've got some particles which are sculpted up the side of the box, and the torus knot there, and the teapot's obviously behind there as well. So what we can do now is select our blob mesh object there, and then go to the modifier tab, and then we can turn off this off in viewport option here. Now again, this will take a little bit of time to calculate, so what I'll do after I've obviously clicked on this guy, I'll pause the video, and it'll maybe take about a minute or so to surface these guys. It shouldn't take that long because there's not that many particles here. There's obviously several several thousand in the actual scene itself. However, we're only using this accumulation event there. Whatever you do, don't click back at frame 0, otherwise you'll have to go through the calculation all over again unless you've cached the thing to disk. Okay, so I'm just going to turn this guy off, and the system will sit there for a little while it surfaces the geometry, so I'll see you there on the other side. And here's the surface geometry. So what we now need to do is we need to duplicate this, so we're kind of protecting the system just in case we want to re-simulate it later on, so we don't have to start dialing in all these settings all over again. So to do that, what we need to do is we need to create a clone of the blob mesh. However, we're actually going to use an instance, not a copy. If we use a copy, the blob mesh is going to have to be recalculated over again. If we create an instance, it doesn't need to recalculate the surface geometry because it's just literally creating a direct duplication of the original. So therefore, just click on OK. All we now need to do now, because we just want this geometry situated as is, we can just right click and convert to either an editable mesh or an editable poly. So I'm just going to choose an editable poly. So now it's collapsed down, and we can just go through and start poly pushing things around if necessary, or adding some parametric deformers and that kind of thing. So now we can go all the way back to frame 0, and we've got our collapsed geometry in situ. So I can go into the particle flow and turn off the main system. So that's obviously going to turn off the blob mesh as well. So therefore, if I scrub through back and forth, obviously nothing's happening. Now I'm going to reselect this geometry here. Oh, here we go. Blob mesh, there we go. And the first one I'm actually going to add is a cap holes modifier. Let's just pull that out again. And the reason behind that is occasionally blob mesh does yield a few holes in the actual geometry that it produces. So therefore, I'm just going to make sure that any small single polygon holes are actually filled in, so that when we actually smooth the geometry out, there's no kind of big gaping gash that you can see through to the underside or to the back surface of the surface geometry. Okay, so I'm also going to smooth it with the old face as well, so it kind of smooths it from the original geometry and also the new stuff as well, so it kind of blends in nicely. Now the next modifier I want to add is a push modifier to get these surfaces to bulge out a little bit before I relax them down, so it kind of smooths out these guys a little bit more without shrinking the mesh in. So what I want to do is I just want to pull in and just grab this guy here, and this I'm just going to expand it out by about a value of 5. Now you'll notice it obviously creates these kind of dark areas, which is obviously overlapping geometry, so there is obviously some issues there. So we now need to add in a relax. I'm just going to pull this down here like that, and then this guy I'm just going to simply just modify it and take this keep boundary points fixed, so it does it for the entire geometry itself. And you notice it's kind of smoothed it out nicely as is. It's got this kind of nice rock lava effect present as it currently stands, which looks pretty cool. However, we actually want to relax this out even further. We actually want to set this iterations value all the way up to about a value of 30. Okay, one last push that we need to apply, and that's going to be in the opposite direction of what we just applied to put it back to what it was originally. So scroll down and bring this guy here, and this value I'm actually going to go and set to -5. So that pulls that in, and you'll notice we've got a few little smoothing issues again. So again, same deal as before. I'm just going to add a relax modifier on top of that. Okay. Again, taking boundary points fixed off, and this one I'm going to crank up to 30 as well. So that's pretty much it. We've got this nice kind of collation being sculpted up the side of the geometry. Same deal here. You could actually select these polygons around here and kind of push them out a little bit more to create like a larger snow drift, and also trim these guys off at the back here so they don't, so it kind of comes in a little bit more like that. That's pretty much it for the most part. I think we'll just add in a white material just to give a rough indication of what this thing will look like. I'll just switch to the perspective viewport and let's just swing around this thing And let's have a quick look. So we've got these nice kind of collation of surfaces around here. This isn't too bad around here. We could actually pull this in a little bit around here. You notice that we've got, because of the pushing and the relaxing, we've got a few small issues down here. This tearing guy, this guy down here is kind of torn off and a little bit too small. And we've also got one of these guys up here as well, which is due to the speed test up there. Obviously there was one particle or a couple of particles which tested true in the speed test all the way back here, so we need to just amend the speed test value just to get rid of that guy. However, the beauty of actually having this down as the collapsed geometry, we can literally just go in and select the relevant elements that we don't want. Can we actually get rid of that guy? No, we can't at the moment. We just need to kind of like cut that off there and just stitch it back together and just get rid of these guys here. But anyway, so we can just grab these. Oh, there's another one there. Missed that one. These guys can actually go. Just delete them, and then all the way back up to the top of the stack, and that's pretty much our snow accumulation finished. Like I said previously, you could apply this collation effect to the entire ground surface, so we've just simply got some of these guys at the back shining through that obviously don't have snow acquired to them, and also you'll get a nice almost shadow effect of where there's no snow being collated on the ground, obviously because the geometry is occluding it, and you've obviously got the particles which are arriving on the which are collating on the geometry itself. So to do that, it is simply a case of just wiring the output of this guy onto here as well. However, you will obviously have a lot more calculation time to produce the surface blob mesh. It'll obviously take a lot longer to produce, quite simply because you've got a lot more particles to obviously calculate. So that's the end of the Q&A. Hope you've enjoyed it, and I'll see you next time. Thanks a lot. Cheers.